Beneath the surface of the equatorial Pacific, in a stretch of ocean no ship ever crosses without instruments picking up something, a pulse of warm water nearly 8 degrees Celsius above normal is moving east. You cannot see it from a boat. You cannot see it from a plane. It sits 200 meters down, invisible, patient, and it has been building since the earliest weeks of this year. Scientists have a name for it. They call it a Kelvin wave. And in July, the team tracking this one confirmed something almost unheard of in 150 years of ocean temperature records. This pulse of heat isn't just large, it's moving faster and building higher than the two most famous El Niño events in modern history, the 1997 event and the 2015 event, the two that reshaped how an entire generation of scientists understood what this pattern was capable of doing to the planet's weather. And this time, the forecast doesn't stop at matching those records. Multiple independent model ensembles now show a real chance this event could become the strongest El Niño ever measured, potentially surpassing a benchmark set all the way back in 1877. Today we're breaking down exactly what's happening beneath the Pacific right now, why this El Niño is developing in a way scientists say is genuinely unusual, what the last 3 record-setting events actually did to the planet when they peaked, and what this specific pattern is already signaling for the months ahead, from droughts on one side of the world to floods on the other, and a counterintuitive twist buried in the forecast that catches most people off guard. No dramatizing, no guessing, just the ocean data, the published forecasts, and what the scientists tracking this are actually saying. If patterns like this matter to you, subscribe now so you don't miss the next major update the moment new data comes in, and a thumbs up helps this reach more people who need to see it. Let's get into what's actually happening in the Pacific. To understand why this particular event has climate scientists using words like historic and off the charts, you first need to understand what El Niño actually is, because it's one of those terms that gets thrown around constantly without most people knowing the mechanism behind it. Under normal conditions, trade winds blow steadily from east to west across the tropical Pacific, pushing warm surface water toward Asia and Australia, while cooler water wells up from the depths off the coast of South America. El Niño is what happens when that entire system breaks down. The trade winds weaken, sometimes reverse entirely, and instead of warm water piling up in the western Pacific, it sloshes back eastward across the ocean basin, eventually surfacing off the coast of Peru and Ecuador. The Spanish name itself, meaning the little boy or the Christ child, comes from South American fishermen centuries ago, who noticed unusually warm coastal waters typically arriving around Christmas and disrupting their normal fishing patterns. That single regional ocean shift, warm water piling up where it normally doesn't, ends up altering atmospheric pressure patterns and jet stream behavior strongly enough to change rainfall and temperature trends across almost the entire planet, from droughts in one hemisphere to flooding in another, months before those effects ever arrive. Scientists identify and measure El Niño using a stretch of ocean called the Niño 3.4 region, a defined rectangle of the central equatorial Pacific, whose sea surface temperature anomaly, meaning how far above or below its long-term average the water is running, serves as the primary tracking metric for the entire event. When that anomaly holds above roughly half a degree Celsius for several consecutive months, forecasters officially declare El Niño conditions. When it crosses 2 full degrees Celsius above average, the event graduates to what scientists call a super El Niño, a designation reserved for only the most extreme cases the record has ever produced. Here's where the current event starts to separate itself from anything in recent memory. At the beginning of 2026, the tropical Pacific wasn't just neutral, it was still showing La Niña-leaning conditions, the cooler opposite phase of this same climate pattern. By April, the ocean had settled into a neutral state, no clear signal in either direction. Then, through May and June, weekly Niño 3.4 readings surged past the official El Niño threshold and kept climbing without pausing, prompting the United States Climate Prediction Center to move the region from a formal El Niño watch to a full El Niño advisory by mid-June. By late June, the Niño 3.4 region was already running about 1.8 degrees Celsius above normal, a value most El Niño events in history never even reach at their absolute peak in the dead of winter. And this event was posting that number in early summer, with months of expected further intensification still ahead of it. The engine behind that rapid climb is the same Kelvin wave mentioned at the top of this video. And it's worth understanding exactly how it works, because it's the single best tool scientists have right now for judging how much stronger this event is likely to get. Earlier in the spring, a rare cluster of tropical cyclones moving through the western Pacific generated an unusually strong and sustained burst of westerly winds, blowing in the opposite direction from the normal easterly trade winds. Those winds mechanically pushed a massive volume of warm surface water eastward across the basin. And as that water moved, it also built up a reservoir of exceptionally warm water beneath the surface, along the boundary between the ocean's warm upper layer and the cold, deep water below, a boundary scientists call the thermocline. That subsurface reservoir is the actual fuel supply for the surface warming still to come. As of the most recent readings in August, that subsurface anomaly across the top few hundred meters of the tropical Pacific was measured at roughly 7 to 8 degrees Celsius above normal at its core, and critically, that reservoir is still filling rather than draining, which tells scientists the surface, warming still visible right now, has not yet run out of fuel. By early August, Australia's Bureau of Meteorology recorded a relative Niño 3.4 value, a version of the index adjusted to allow fair comparisons against events from decades ago, despite the background warming of the entire ocean since then, at plus 2.2 degrees Celsius for the week ending August 9th. That relative measure is the specific number the Climate Prediction Center has been using to describe this event as potentially historic, because it strips out the general warming trend the whole planet has experienced since the 1980s, letting scientists compare this event honestly against the giants of the past rather than being fooled by a warmer baseline ocean. By the middle of August, the Climate Prediction Center's own discussion placed the odds of this event becoming a very strong El Niño above 90% for fall and winter, and gave the October through December period a 69% chance of exceeding every single El Niño event on record, dating back to 1950. To put that number in context, only 3 El Niño events since satellite monitoring began have ever qualified as genuinely super in strength: 1982, 83, 1997, 98, and 2015-16. Multiple independent research groups modeling this year's event, drawing on dozens of forecast ensembles run by different national weather agencies around the world, have found that the current trajectory is developing faster than the 1997-98 event, long considered the gold standard for how explosively an El Niño can intensify. And unlike the 2015-16 event, which had the advantage of starting from an already warm ocean left over from a weaker event the year before, this year's event launched from genuinely cool, La Niña-leaning conditions back in January, making its climb even more remarkable by comparison. Climate researcher Zeke Hausfather, who compiled peak monthly Niño 3.4 anomalies for every recorded El Niño event stretching back to 1877, found that no event in nearly a century and a half of observations has ever pushed meaningfully past 2.75 degrees Celsius at its peak, a mark essentially tied between the legendary 1877-78 event and 2015-16. The forecast ensemble for this year's event, drawing on the weighted median of hundreds of individual model runs from more than a dozen forecasting centers worldwide, currently sits entirely at or above that all-time record, with even the lower end of the model spread grazing the historic mark, and the expected peak landing somewhere in the range of 3.5 to 3.6 degrees Celsius, an outcome that, if it verifies as forecast, would make this the strongest El Niño ever directly measured. It's important to be precise here rather than overstate where things stand, because this is still fundamentally a forecast rather than a settled fact. Individual models disagree on exactly when the peak will land, some pointing to November, others to December, and the surface signal, while extraordinary already, still has to continue tracking the subsurface heat reservoir upward through the coming months for these projections to fully verify. The World Meteorological Organization's own outlook, issued this month, describes El Niño as continuing to intensify steadily and expected to dominate global climate patterns through the August to October window, with high confidence and continued strengthening. But the organization frames this in terms of probability and expected impact, rather than a locked-in certainty of setting an outright record. That distinction matters. What's genuinely established, not speculative, is that this event is real, already registering as a strong El Niño by every major international monitoring agency, and tracking toward the upper edge of what any El Niño has ever produced. So why should any of this matter to someone who has no connection to oceanography, and has never heard the term Kelvin wave before this video? Because the last 3 events that reached this exact threshold reshaped weather across the entire planet, and the damage wasn't confined to any single country or continent. The combined global economic toll from the 1982-83 and 1997-98 Super El Niño events alone has been estimated at somewhere between $4.1 and $5.7 trillion in income losses worldwide, spread across agriculture, energy markets, infrastructure damage, and public health systems strained by extreme weather on multiple continents simultaneously. The 1997-98 event alone triggered catastrophic flooding across Peru and Ecuador, fueled some of the most destructive wildfire seasons Indonesia had experienced up to that point, as historically wet rainforest regions turned tinder dry, and contributed to a global coral bleaching event significant enough that it remains a reference point for marine biologists studying ocean heat stress today. The 2015-16 event produced similarly severe consequences, worsening drought conditions across southern Africa and parts of Southeast Asia, while driving destructive flooding in other regions, and directly contributing to 2016 becoming, at the time, the hottest year ever recorded by direct measurement. That last point deserves its own moment of attention because it connects this ocean pattern directly to the record-breaking global temperatures making headlines throughout 2026. Every time a strong El Niño event unfolds, it releases an enormous amount of heat that had been stored in the deep ocean back into the atmosphere, temporarily nudging the planet's average surface temperature upward by several tenths of a degree Celsius, on top of the underlying long-term warming trend already in progress from greenhouse gas emissions. Climate scientist Daniel Swain, who has been tracking this event's development since the earliest westerly wind bursts appeared in the spring, has been explicit about this mechanism, describing it as one of the primary reasons a strong El Niño year so often becomes the hottest year on record, even without any additional acceleration in the underlying warming trend itself. With 2026 already ranking as the third hottest year in the global temperature record, behind only 2024 and 2025, and a super El Niño now actively intensifying through the back half of the year, scientists are already flagging a real possibility that 2026 or 2027, depending on exactly when the event's heat fully surfaces, could overtake 2024 to become the hottest year ever measured. Now here's where this story gets genuinely more complicated than a simple hotter and stormier headline. And it's the part that actually earns the phrase, "this time it's different," rather than just repeating what every El Niño does. The regional impacts of this specific event are shaping up to be a study in contrasts, sometimes contradictory contrasts, within the very same country. According to the World Meteorological Organization's seasonal outlook for August through October, this event's classic rainfall footprint points toward wetter than normal conditions across the Greater Horn of Africa, a region that has struggled with severe multi-year drought in recent memory, while simultaneously raising drought risk in other parts of the world entirely, including Indonesia and parts of Australia, where El Niño reliably suppresses rainfall and dramatically elevates wildfire risk during the region's dry season. Compounding that risk, forecasters are also tracking a likely positive Indian Ocean dipole developing alongside this El Niño, a related but separate ocean temperature pattern in the Indian Ocean that, when it aligns with El Niño the way it appears to be doing this year, tends to intensify drought conditions across Indonesia and Australia even further, while simultaneously increasing flood risk in East Africa, essentially amplifying both halves of this event's push-pull rainfall pattern at the same time. For the United States specifically, seasonal outlooks built around this event point toward an active, wetter than normal storm track pushing across the southern tier of the country, from southern California through Texas, the Gulf Coast, and into the southeast. A pattern strongly associated with the strongest historical El Niño events, and one that raises real concern for repeated storm systems, flooding, and the kind of collision between cold air and moisture that produces damaging ice storms and heavy, wet snow across the south during winter. Meanwhile, the northern tier of the country is expected to run milder and drier than usual on average, a pattern consistent with how El Niño typically displaces the polar jet stream northward, keeping the coldest air bottled up closer to the Arctic rather than plunging south as often. But here's the twist buried inside this year's specific forecast. The detail that actually justifies calling this pattern different rather than just another entry in a familiar playbook. Even though El Niño winters generally trend milder overall across the northern United States, this year's forecasters are also flagging early warning signs of a disrupted polar vortex for the coming winter, the broad, high-altitude ring of spinning cold air that normally traps Arctic air near the North Pole through the winter months. Multiple separate atmospheric signals are aligning in a way that increases the odds of that vortex weakening or splitting apart at some point in the season, including the unusual strength of this El Niño itself, an active pattern of westerly wind anomalies high in the stratosphere, and unusually low Arctic sea ice in specific key regions this year. None of these signals guarantee cold weather everywhere, and a weaker polar vortex is not a promise of a brutal winter for any single location. What it does mean is a meaningfully increased chance that, at some point during the season, a chunk of that normally contained Arctic air breaks loose from the polar region and plunges south into the mid-latitudes, potentially delivering sudden, sharp cold snaps into parts of the United States, Canada, or Europe even in a winter whose overall seasonal average is expected to trend warm because of El Niño's broader influence. That's the counterintuitive heart of this year's forecast. The same climate pattern nudging the planet's overall temperature upward and pushing a wetter, stormier pattern into the southern United States may also be helping set the stage for exactly the kind of jarring, out-of-nowhere Arctic outbreak that catches an otherwise mild winter completely off guard. It's worth being honest about the uncertainty still built into all of this, because a forecast this far out, covering weather still months away, is never a fixed, guaranteed outcome, and treating it as one would be exactly the kind of exaggeration this channel avoids. The Climate Prediction Center itself, even while raising its confidence in a historically strong event, frames its outlook in probabilities rather than certainties, a 69% chance of exceeding prior records, not 100%, Different model centers around the world, including the European Center for Medium-Range Weather Forecasts, NOAA's own CFSV2 model, and the North American Multi-Model Ensemble, broadly agree that this event is strengthening rapidly and heading toward genuinely rare territory. But they still show some spread in exactly how high the eventual peak will land and exactly when it will arrive. That spread is normal, expected, and part of how long-range forecasting honestly works. What isn't in serious dispute among the agencies tracking this in real time is the underlying trajectory itself, an event that started the year in cool, La Niña-leaning territory, and has since climbed faster than the two most famous El Niño events in the modern record, fueled by a subsurface reservoir of ocean heat that, as of the most recent readings, is still filling rather than draining. So what does all of this actually mean for someone watching this unfold from the outside, waiting to see how the rest of this year and next winter actually play out? It means the ocean is currently running an experiment humanity has only witnessed a handful of times with modern instruments, watching closely. And every one of those previous instances left a measurable mark on global weather, global temperature records, and, in some cases, entire regional economies. It means the southern United States should reasonably expect a more active, wetter storm season heading into winter, while the northern tier trends generally milder, but with a real elevated chance of at least one sharp, disruptive Arctic outbreak slipping through if that weakened polar vortex signal verifies the way current data suggests it might. It means drought and elevated wildfire risk are increasingly likely across Indonesia and Australia as the year continues, while East Africa should brace for a wetter than normal stretch after years of punishing drought in that same region. And it means 2026, already sitting at third place on the list of hottest years ever recorded, now carries a real scientifically grounded chance of climbing higher on that list before the underlying ocean heat driving this event finally starts to fade. None of this requires exaggeration to be worth paying attention to. The Kelvin wave sitting beneath the Pacific right now is a real, measured physical phenomenon, tracked continuously by ocean buoys, satellite altimetry, and a global network of climate agencies who don't always agree on every detail, but who broadly agree on the scale of what's building. Whether this specific event ultimately breaks the all-time record set in 1877, matches the legendary events of 1997 and 2015, or falls just short of history once all the data is finally in, the practical reality for the months immediately ahead is the same. A major global weather pattern is intensifying faster than almost anything scientists have directly measured before, and its effects, the storms, the droughts, the temperature records, and that counterintuitive risk of Arctic cold slipping through a generally mild winter are already beginning to show up in the forecasts. Meteorologists are watching update by update. That's the complete picture of what's actually happening beneath the surface of the Pacific right now, a Kelvin wave of ocean heat moving faster than the two most famous El Niño events in modern history, a forecast trajectory that genuinely could break 150 years of temperature records, and a set of regional consequences. From drought in Australia to flooding in East Africa, to the strange possibility of Arctic cold breaking through an otherwise mild American winter that scientists are tracking in real time as the data continues to come in. We'll keep following every update, as this event either verifies these historic projections or settles into something closer to prior events. If you want to know the moment this forecast shifts one way or the other, subscribe and turn on notifications. Drop a comment if you've already noticed unusual weather where you live this year. See you in the next one.